So number 33, Albert chooses a card from the at random from the card shown below. What's the probability that the card is an S? Well, there are 2, 4, 6, 8, 10. There are 11 possibilities. 11 possibilities, and only one of them is an S. Number of successes over the number of possibilities. What's the probability of an A or a T? Well, again, there are 11 possibilities. An A or a T, what counts as a success? If I get an A or a T, it counts as a success. So let's count all the successes. If I got an A, 1, or a T, 2, or an A, 3, or a T, 4. So there are 4 out of 11. Getting a D, 0 out of 11, and there's so it's a 0% chance of getting a D, and there's a 0% chance you'll get a D on this exam if you watch these videos. Okay, a vowel. Good thing there's no wishy-washy Y's here, because Y's can be a vowel sometimes, right? So the probability of getting a vowel are these 4 cases, and there's 4 cases out of 11 that are vowels. Billy's buying food for the class party. On his first trip to the store, 8 bags of pretzels and 4 bottles of iced tea. He paid $48. On his second trip, he bought 5 pretzels and 2 bottles of iced tea and paid $28. Define the variables. And so let's just make it well, we could do P is for pretzels and T, but let's be original. Let's do let's do P for pretzels and Q for iced tea. So this is a T, and this is pretzels. And I picked those for a reason. Write a system of linear equations to model the situation. So he bought 8 bags of pretzels, so we got 8P plus 4Q, so 4Q, and that's got to equal 48. And then he went back and he bought 2 pretzels, so 2P. Oh, and a second trip, here we got 5 pretzels, 5 bags of pretzels. 5 pretzels plus 2Q, and that's got to equal 28. Solve the system using elimination to find the price of a bag of pretzels and the price of a bottle of iced tea. Well, when you look at this, you see there's 4Q up here, and there's 2Q down here. So if we did the equation number 1, here's equation number 2. If we did equation number 1 minus 2 times equation number 2, we'll get this 4Q minus 4Q, and well, that'll be 0. So that's the plan. So here we go. 8P minus 2 times 5P, so that's 8P minus 10P is minus 2P. 4Q minus 4Q is 0Q. And we have 48 minus 2 times 28. 2 times 28 is 56. Subtracted from 48, we would get minus 8. So mental math time, P is equal to, that's right, $4. P is equal to 4. Remember, that's the price of a bag of pretzels. And we go and put P equals 4 into pick an equation, 1 or 2. Just look for always pick for the equation that's going to have the lowest numbers, and that's number 2. So we put P equals 4 in there. So let's do 5 times P, which is 4, plus 2Q is equal to 28. Let me make that look like a Q. So this is 20 plus 2Q equals 28. 2Q equals 8. So Q is equal to 4. So there's our answer, 4 and 4. Make a scatter plot for the data in the table. Oh, then we're going to have to do some other junk. So 1, 3, there's our first point. 2, 4, 6, 6. Oh, 8, 4, and 10, 6. Describe the correlation. Describe the correlation. I would say the correlation is low. I don't know another way to describe it. Draw the line of fit. Looks something like, maybe something like this. Gosh, I hope that's what you're looking for. All right. The value of a house can be modeled by this function, where x is the number of years since the house was built. Okay, that's cool. So look at time 0, right? This number, if at time 0, we want to know what the house is worth. The house is worth 1 point blah 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 to the 0, which is 1 times $495,000. That's a pretty nice house. So the initial amount, oh, there we go. So at x equals 0, right? Because that would be right when the house is built, would be 495,000. The growth factor is going to be all of this stuff right here. It's 1.0462, and the growth rate, you can see that the house is going to grow at 4.62%. I think you've done a lot of these. Reuse the equation to find the value of the house after the following years. Okay, so this we can do in the calculator pretty easily. It's 1.0462 times 1.0462 times 495,000. So this is at year 2, 541,795. 541,795. And times 0, we already said this is 495,000. Now each time we could just take this, and this is going to be 2 more periods, so we multiplied by 1.0462. That would be year 3 times the next year, 1.0462. 593,013. 593,013. 593,013. And I'm not going to fill out the rest of this, but you get the idea, I hope. Graph the function. Okay, so it's going to look like this. At year 0, where are we? 495,000. Then it's going to go to year 2, right here. It's going to go to 541, then 593, and it's going to look something like that. How long would it take to double? Oh man. I can tell you that it's going to be something like 10 years, 9 years maybe. You get it from your graph. There's going to be some number in the middle here, maybe between 8 and 10, that's going to have to get the 100,000 hit the 1 million mark, I think. Oh, it's not going to double in this period. Okay, well, I'll pick up from here in a second.